Good morning to all. Let us start the lesson force and pressure. Now, in this, I am going to cover the following points: force and its effects, contact and non contact forces, pressure, pressure exerted by liquids and gases, atmospheric pressure. So, let us understand the force. Now, as you already know, that force is the push or pull on an object. For example, if an object has to be moved, it has to be pushed or pulled. As from the figure, you can easily see that if you want to change the position of the car, then you have to push it. The child is striking a ball to change its direction. The football player will kick the ball to move it, or the bullock cart, the cart, the person is pulling to move the objects. The cart is horse is pulling the cart. The rope is pulled by the children. The means force is the push or pull on an object. Now, force are due to interaction. An interaction of one object on another object results in a force between the two objects. For example, if a man stands behind a car, the car does not move if he pushes the car. He applies force and the car begins to move in the direction of the applied force. Now, if two forces act on a body in the same direction, the net force is the sum of the two objects. Here, the two forces both are acting in the same directions, so they will add up and the total force will be F1 plus F2. If the two forces act in opposite directions, like F1 is in this direction and F2 is in this direction, these two forces are in the opposite direction, so the resultant force, net force, will be the difference of these two objects. So effect on the object depends upon the net force acting on it. The effect of force on an object. Force can make an object to move from rest. Force can stop a moving object. Force can change the speed of an object if it is moving. Force can change the direction of a motion of an object. Force can change the shape of an object. Force may cause one or more of these effects. So, you can move an object from the rest, like in this figure. You can stop the moving object. You can change the direction. Here in this figure, the direction is changed. You can change the speed of an object if it is moving. You can change the shape of an object. So all this figure shows that the effect of the forces on any object. Now, types of forces. There are mainly two types of forces. One, the contact force, another is non-contact force. Contact forces are exerted by one object on another when they are in contact. Contact means when they touch to each other. The contact forces are of the two types. One is the muscular force and that second is the force of friction. Non-contact forces, they are exerted by one object on another when they are not in any contact with each other. For example, the magnetic force, electrostatic force, gravitational force. Now, you can see in your daily examples that whenever you touch any object, then by using the muscular force you can apply the force on any object. In case of the magnet can move an object at a distance. If you put an iron object in front of a magnet without touching, the iron object moves towards the magnet. So without any contact, the magnet is applying the force. Similarly, the electrostatic force and the gravitational forces, they are non-contact forces. Now, contact forces, muscular force. Muscular force is the force exerted by the muscles on a of our body. We use muscular forces of our various activities. Animals like bullocks, horses, camels, donkeys, elephants also use muscular force to perform various tasks. Force of friction. Force of friction is the force which opposes the motion of an object over a surface. A ball rolling on a ground gradually slows down and comes to rest due to force of friction between the ball and the ground. If we stop paddling a cycle, it gradually slows down and comes to stop due to force of friction which is acting between the tires of the cycle and to the ground. Now, non-contact forces. Magnetic force is the force exerted by the magnet. For example, force of attraction and repulsion between two magnets, force exerted by magnet on a piece of iron or a steel. So, from this figure, you can say if you bring the opposite poles of a magnet, they attract towards each other. If you bring the same forces, same poles nearby it, they repel each other, and the magnet they moves in opposite directions. Like south poles, they repel north, they repel, but south and north they attract to each other. You in this figure you can pick up the nails, the nail you can pick the small nails with the help of a magnet. Now, electrostatic forces. Electrostatic force is the force exerted by the charged body on another charged or uncharged body. For example, a plastic straw charged by rubbing with paper attracts a suspended plastic straw. If you put bits of paper on the paper and take a comb, you rub on your hair, then you will and rubbed hair on rubbed comb. If you bring on the bits of paper, it will attract all the bits of paper and a chain of the bits of paper will follow. ये छोटा सा गेम आप लोगों ने बचपन में ज़रूर खेला होगा. अगर नहीं खेला है तो आप करके देख सकते हैं. पेपर के छोटे छोटे टुकड़े करिए, कोम लीजिए, उसको हेयर पे रब करिए एंड ब्रिंग द rub comb near the papers and you will see a trail of the bits of paper will form. Suspended straw charged by rubbing with paper repels a suspended plastic charged by rubbing with paper. The gravitational force. Gravitational force is the force exerted by the earth on all objects. It pulls all objects towards the earth. A coin or pen falls down when it slips off our hand. A ball thrown upward falls down. Leaves and fruits falls to the ground when they get detached from the plant. Water in rivers flows downwards. So in all these examples you see that the gravitational force is acting without in contact with the objects. Now pressure. Pressure is the force acting on unit area of a surface. So sometimes the force is also misunderstood with the pressure. Now pressure is the force, but it is the force acting on unit surface or unit area of a surface. So pressure is equal to force upon area. If the area is small, the pressure is more on the surface for the same force. Let us see that it is easier to push a nail into a wooden plank by its pointed end than its head because the pressure is more. If more pressure, then its effect of the force will be more if the area is less. So that is why it is easier to push a nail from its pointed end. It is easier to cut vegetables with a sharp knife than a blunt knife because the pressure is more on a sharp knife. Shoulder bags having broad and not thin straps to reduce the pressure. If the shoulder bags they have the broad strips, then area is more, then pressure is less using this formula. If area is more, then pressure is less. If area is less, then pressure is more. Now pressure exerted by liquids. Liquid exert pressure on the walls of a container. Liquid exert pressure on the bottom of a container. It depends upon the height of the liquid column. It exerts sideways pressure. Liquid exerts equal pressure at the same height. So all these you can see with the help of this. If you have a tube filled with water and if you put a rubber ball balloon under it, then you will say that size of the balloon is increasing. That is because the pressure exerted by the liquid. Liquid exerts pressure on the bottom of a container. It also exerts pressure on the sideways. If there is a hole on sideway and if you put a balloon over it, you can easily observe that pressure is exerted by the water on the balloon. If you put holes on all the sides of a container, then the water comes out. That shows that liquid exerts sideways pressure. Now pressure exerted by the gases. Gases also exerts pressure. Gases exerts pressure on the walls of a container. You can easily see that it is a tube filled with air. This is a rubber balloon. It is filled with air, and this is the tube filled with air which is used to float on the water. So all these gases exert pressure on the walls of a container. Now atmospheric pressure. Atmospheric pressure is the pressure of air around us. Atmospheric pressure is due to the weight of air. The weight of an air column of the height of the atmosphere and area 10 by 10 centimeter is large as 1000 kg. So if you imagine an air column of area 10 by 10 centimeter, 10 by 10 centimeter means it is less than of your foot, your scale which you use. Small scale 6 inches scale is of 15 centimeter, means less than 10 centimeter, 10 by 10 centimeter. And if you consider the air column of the height of the atmosphere and area 10 by 10 centimeter, then its weight of the air is more than 1000 kg. So just imagine so much air pressure of the air is exerting on your head, but you are not experiencing any pressure. Do you feel any pressure on your head? No, we do not feel any pressure on the head because it is balanced by the pressure inside our body due to the flow of the blood. So that is why we do not feel any pressure of the air on our head. Now this was the experiment also to show the atmospheric pressure, how large is the atmospheric pressure. Now two rubber suckers, he joined the two rubber suckers, and with the rubber suckers all the air is taken out. So now there is no air inside it. So the atmospheric pressure falling from outside on these air sucker is so high. It's so high that the 4 horses over here and the 4 horses on this side, they are not able to remove or to separate out these suckers because of the large amount of the atmospheric pressure falling on these suckers. So you can imagine that atmospheric pressure is so very large, but we do not feel on our head because of the pressure inside our body because of the flow of the blood. So that is all for this. Thank you and have a nice day.